I'll tell you when you can turn it back on. Just give me a minute. So with the radiant barrier and with the maximum vacuum that it can pull, seems to be stabilizing at around 731.4 on the first thermocouple and 739.9 on the bottom thermocouple. Here we have the chamber with the bare acrylic walls without the radiant barrier. As you can see, mostly transparent, and acrylic is quite permeable by infrared radiation, so you should see a lower steady state temperature. Backradiation theory is correct. We should see a substantially lower steady state temperature with the radiant barrier removed. The radiant barrier is removed. We can see the temperature is steadily crawling up back to what's likely going to be around 730 or 740, even without any backradiation mechanism. So this with an oil did get, of course, quite hot, but it should not have the ability to concentrate and reflect that radiation back onto the heating source. Now, some people might say, well, that's a relatively small surface area, it shouldn't, that wouldn't necessarily be able to absorb that much radiation, but since it's scattering in all directions, since we have the back sidewalls and top covered with a radiant barrier, it should have absorbed a significant amount of that radiation, even if it has a relatively small surface area. It shouldn't have an effect. So there we are, almost back to where we were with the radiant barrier. We recalled that it would not really go above 740. Power usage is about the same. And our vacuum was exactly where it was with the radiant barrier. So the presence of gases should not have an effect. The gases will heat up whether or not you have the radiant barrier inside, and since air is mostly non-IR active, it should not be really any different. Let's see whether it goes back to the lower number was 740 and the higher number was about 730. Of course, for backradiation to be real, it has to have more than a few degrees of warming. It should be able to, in theory, nearly double the temperature as climate science claims that the atmosphere on Earth can do. So our steady state temperature without the radiant barrier is around just a little bit under 730 on the first thermocouple and just a little bit under 740 on the bottom thermocouple. So it does appear that the radiant barrier was able to increase it by a few degrees, but nowhere near the effect that backradiation would predict, because the intensity of the radiative flux in this container, this chamber, would be predicted to be much greater with the presence of those aluminum radiant barriers. It should be scattering radiation and reflecting radiation back to the heating element. And and that obviously does not happen because the temperature is only a few degrees lower. Now seems to have gone over 741 on the bottom, which is very close to our 745 value that we reached, and it's getting close to 730 at the top. So there is in effect no difference between having a radiant barrier and not having a radiant barrier. So we reinstalled the radiant barrier, and the radiant barrier effectively covers four sides of the box. The bottom is still transparent, and the front, the door is still transparent, but both the top and the sides are covered. That should have an effect of reflecting, at least half of the outgoing radiation. So it should have a substantial backradiative effect. And so we'll see if our temperatures climb above 740 on the lower thermocouple and about 730 on the high thermocouple. We have the same vacuum with the same power draw. So all the parameters really haven't been affected by the radiant barrier. It should be isolating the radiative effect. So it's still climbing. Climbing more slowly than at first. The top one is perhaps starting to stabilize, 728.4. It's going to go to 730. Top one doesn't seem to be moving anymore, so 731, 731.0, that's about where it's going to go. At this steady state temperature, it's still climbing a little bit. Does not seem to be going above 731. It appears we've reached our maximum steady state temperature that this resistive heater can produce, drawing 160 watts of power, and we appear to have no backradiative effect. Radiation, the radiant barriers made no difference. And this is have a lot more of a radiant barrier than a gas like CO2. So having four sides of the vacuum chamber lined with a highly emissive, highly reflective, low emissivity coating like this, especially with all these folds, that even increases the scattering effect. So let's maybe go to 130, 732 now. And it has not gone to 745. It actually, without the radiant barrier, it went all the way up to, I think 740. So appears to be no greenhouse effect. You can see from the outside how this wall is covered, the back wall is largely covered, and the side wall here covered. And of course the top is completely covered, so even just the presence of one radiant barrier should have a very substantial back radiative effect. Eventually we will try to cover all 6 walls with the radiant barrier, but we shall see. Okay, it's gone to 729. So 736.1, not going much above that. That is a lot of scattering radiation, you can imagine that. 4 sides almost completely covered, and no effect on temperature. So the conclusion of the experiment is that the presence of a extremely reflective radiant barrier like aluminum, which has an emissivity of 0.05, has no effect on the steady state temperature of a resistive heater placed in a vacuum chamber to isolate convective or conductive effects of the presence of gas, compared to a transparent vacuum chamber made of acrylic, which has an emissivity of 0.95, so it should be able to absorb much more radiation than of course the aluminum. So the hypothesis is that back radiation can heat something that's hotter than itself. So in other words, the reflective radiant barrier being colder than the heat source can heat the heat source to a value greater than the heat source's initial temperature. And that hypothesis has been falsified with a very simple experiment such as this one. And I believe this may be the first experiment on back radiation of this kind. That would love to be pointed to other experiments that may have used similar vacuum configurations to ensure that the presence of gases, which have different heat capacities and convective and conductive effects, does not in any way create false positives. I think creating vacuum conditions to isolate a pure radiative phenomenon is very important. And that's what we're doing here. It's not a pure vacuum, but it's pretty close. Close to a pure vacuum. Almost 14 psi, which means there's like 0.7 psi of air left, so it's effectively the pressure of Mars, not much in the way of an atmosphere.